Good afternoon, algebra students. If you have finished your test and you want a little extra help on how to do this worksheet, then this video is for you. Okay, one side is looking at the divisibility rules of a number. What I mean is, how can we look at a number and tell if it's divisible evenly by 2, 3, 4, 5, 6, 9, or 10? I'm going to look at an example here of 24. How can I tell if 24 is divisible by 2? Well, it's an even number. The last digit is an even number, 0, 2, 4, 6, or 8. So this is definitely divisible by 2. How can I tell if that number, 24, is divisible by 3? Well, I'm going to rewrite it. How can I tell if 24 is divisible by 3? Now pretend I don't know that it's 8 times 3. Pretend I don't know that it's divisible by 3. How can I tell? By looking at it. Well, the trick is to take the two digits and add them together. 2 plus 4. 2 plus 4 equals 6. Is 6 divisible by 3? Yes. So this number is divisible by 3. By 2 and by 3. Now, if you have some big numbers like you do on this sheet, if you add up the digits to see if they're divisible by 3, it's a little bit easier than dividing the whole thing by 3. So add up the digits. To tell if a number is divisible by 4, look to see if the last two digits are divisible by 4. This one's a little weaker. It's not used very much. But basically what it means is the number divisible by 2, and then is it divisible by 2 again? We're going to look at it that way. So we can tell that these last two digits are 24, so divisible by 4, yes. 4 and 6 go into 24. But you could also divide this by 2, and that's 12. And if you can divide it by 2 again, evenly, and you can, then this number is divisible by 4. So 24, the last two digits are divisible by 4, and I can divide it by 2, and then divide it by 2 again, and still be able to divide by 2 evenly both times. So this is yes to 4. 5. Does 24 end in 0 or 5? No, the last digit is not 0 or 5, so no, this is not divisible by 5. Is this number divisible by 6? Well, we know that it is. We know that 6 goes into that evenly. It becomes 4 if you put 6 in there. But the way to check using our number rules is, first of all, is it divisible by 2? Yes, we said it was divisible by 2 because it's even. Is it divisible by 3? Yes, because the digits add up to a number divisible by 3. So 6. So this number is both divisible by 2 and by 3, so it is also divisible by 6. So the way to tell if a number is divisible by 6 is if it's divisible by 2 and 3, then it is divisible also by 6. To tell if a number is divisible by 9, you add up the digits like we did to see if it was divisible by 3. So we take 2 plus 4, and that's 6. Is 6 evenly divided by 9? No, we get a fraction. If we take 6 and try to divide it by 9, we get 6/9 or 2/3, and that's not a whole number. So it's not divisible by 9. 24 is not divisible by 9. And is it divisible by 10? 24 does not end in a 0, so it is not divisible by 10, so the answer to that question is no. So for this first line, I have 18, and I said yes, it's divisible by 2 because it's even. Yes, it's divisible by 3 because 1 plus 8 equals 9, and 9 is divisible by 3. It is not divisible by 4 because if I divide it by 2, I get 9. If I divide it by 2 again, I can't. 9 is not an even number, so it's not divisible by 4. It's not divisible by 5 because it doesn't end in 5 or a 0. It is divisible by 6 because, well, we know it is because we know 6 times 3 is 18, but It's also, we can tell it's divisible by 6 because it's divisible by 2 and 3. So it is also divisible by 6. A number has to be divisible by 2 and 3 in order to be divisible by 6. Is it divisible by 9? Yes, because 1 plus 8, the two digits add up to 9, and 9 divided by 9 is a whole number, 1. That is definitely a multiple of 9. Is it divisible by 10? No, the number does not end in 0. So that is how you do this chart. Good luck with that one. Now on the other side, I talk a little bit about prime numbers and how to break a number down into its prime factors. For instance, here's the number 12. We're going to make a factor tree, and I think we've done this in this class before. You've done it probably before in your life, but here's a number 12, and I'm going to rewrite it here and just break it down into its prime factors. What are prime factors? Factors that cannot be divisible by anything else but by 1 in itself. So the first 10 prime numbers would be 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. These numbers are only divisible by 1 and themselves. So there's no more factors to be broken down, and that's what we want to do. Break these numbers down into numbers that can't be broken down anymore. So for instance, with 12, you could pick 3 and 4 as factors. 3 times 4 is 12. Now 3 is a prime number. It cannot be broken down anymore, so we leave that one. But 4 can be broken down into factors other than 4 and 1. We can multiply 2 times 2. Now 2 is a prime number. It can't be broken down anymore. So our prime factors for 12 are 2 times 2 times 3. And it's done. I did another example here with the number 40. I need to get a pen. Just a minute. And 40 was broken down into 4 times 10. And then 4 can be broken down even more into 2 times 2, even smaller factors. And 10 can be broken down into smaller factors of 5 times 2. Now all of these numbers are prime. 2 times 2 times 5 times 2 are all prime numbers. There's no other factors besides themselves and 1. So the final answer for 40 is 2 times 2 times 2 times 5. And I put them in order from smallest to largest. And I made it equal to 40. And that's true because 2 times 2 is 4 times 2 is 8 times 5 is 40. So it worked. These are the prime factors of 40. Here I have some variables. I just wanted to show these to you as an example. 4x cubed, well 4 can be broken down into 2 times 2, and then we can take x cubed and break that down into x times x times x. And there's the factorization of 4x cubed. 2 times 2 times x times x times x. And here 18 is broken down into first 6 times 3, and then I can break 6 down into 3 times 2, and now I have 3 times 2 times 3. Those are the prime factors, these ends of the branches. And I rewrote it with as 2 first, and then times 3 times 3, and then times x times x. We're going to use this skill tomorrow to learn how to simplify radicals. So please take your sheet here and break these numbers down into their prime factors. I kept them fairly small. Just to kind of give you an idea, I'm going to do another example just to make sure you know how to do it. I'm going to take, for example, let's see, 48. So for my example, 48, I'm going to break this down into prime factors of 16 times 3. And I can break 16 down into 4 times 4. And my prime factors are now 3 times 4 times 4, and I'm done. But you could also do 48 by dividing it by, say, 2. 2 goes into that 24. Then I can break 24 down into 6 times 4. Then this can be broken down to 3 times 2, and this can be broken down to 2 times 2. And now I'm all primed up. And my answer is 2 times 2 times 2 times 2 times 3. Have fun, and I'll talk to you later.